In this video, we are going to discuss a few questions on states of matter for IGCSE Chemistry. Now, look at this question. Solid X is heated for 600 seconds. The graph shows the heating curve that is obtained, 0 to 600, and the temperature increases. Now, it reaches a constant temperature region, that is change of state. Again, it being heated. Now, there is another constant temperature region, that's another change of state. So it's a solid X. A solid is heated, it melts, then it's heated again, it boils. So the solid X melts here, it becomes a liquid, then it boils here. So what is the melting point of X? It has to be 170. Four physical changes of ethanol are listed: condensation, evaporation, freezing, and boiling. In which changes do the particles move further apart? Condensation, particles come closer. Freezing, particles come closer. It has to be 2 and 4. 2 and 4 is the answer. Nitrogen is heated in a balloon which expands slightly. Which statements about the molecules of nitrogen are correct? So they move further apart, which is correct because there is a slight expansion. They move more quickly, that's correct because they are heated. Higher the temperature, higher kinetic energy. They remain the same distance apart, it's contradictory to the statement 1. Their speed remains unchanged. Now it's again contradictory to the statement 2. So it's 1 and 2. Substance M is a solid at 30 degrees Celsius. The substance is heated to 80 degrees Celsius and its temperature measured as it cools down to room temperature. So it's a solid at 30, right? It's a solid at 30. It has been heated to 80 and let it cool down to room temperature. So we have a cooling curve here. Between which times is substance M freezing, right? It's a solid at 30, so it must be above 30. So this has to be the times where the substance M is freezing. So Q to R. A gas is placed in a sealed container. The gas has a pressure of 1 atmosphere and a temperature of 50 degrees Celsius. It is heated to 100 degrees Celsius. Which row describes the cause of the pressure of the gas and the effect of increasing temperature of the gas? Cause of gas pressure. Alright, what causes gas pressure? Collision between gas particles? No. Collision between gas particles again. Collision between gas particles and the container. That's right. Now, the effect of increased temperature on the gas. Collision become less frequent. Now it's the opposite. The collision become more frequent when there is a higher temperature. The average speed of the gas particle increases. That's right. Because temperature is the average kinetic energy. Part of a cooling curve for water is shown. Temperature in time. What is occurring between points X and Y? So it's a cooling curve. Water is a liquid. Here at 0, water freezes. So it's a freezing point, right? So steam is condensing into water. No, it should happen above 100 degrees Celsius. The temperature of the water is decreasing. No, the temperature remains constant. So whenever there is a change of state, the temperature will remain constant. Ice is melting. No, it's a cooling curve. Ice melting or melting will come on a heating curve, not on a cooling curve. Particles are losing heat to the surroundings, which is correct. A sample of gas occupies 340 centimeter cubed at room temperature and pressure. The temperature and pressure are both increased, but the volume occupied by the gas remains constant. Which row describes what happens to the particle speed and the average distance between the particles in the gas when the temperature and pressure are both increased? So particle speed will increase because temperature, an increase in temperature will cause the particles to move faster. Now what happens to the average distance between the particles? It should be unchanged because their volume remains constant. In which state does 1 decimeter cubed of methane contain the most particles? Gas at 100 degrees Celsius, no, particles will be further apart. Gas at room temperature, again a liquid, a solid, particles are closer together. The diagram shows the changes of state between a solid, a liquid and a gas. In which changes of state is energy being given out? So energy is being given out here as well as here, so 4 and 3. Which description of Brownian motion is correct? Random movement of particles due to bombardment by larger particles? No, it's actually the bombardment by the smaller particles. It's wrong. Random movement of particles from a low constant, that's actually not the case. 1 cm cube sample of substance X is taken. This is sample 1. X is then converted into a different physical state and 1 centimeter cube is taken. This is sample 2. Sample 2 contains more particles in the 1 cm cube. Alright, so this must be the reverse process, the energy releasing process. Which process caused this increase in the number of particles in 1 cm cube? Boiling will decrease it, condensation will increase, evaporation will decrease it, sublimation will decrease it. So it has to be B. Which row about the change of state is correct? Change of state, solid to liquid, heat is given out and no heat is required. Gas to liquid, heat is taken in, no heat is given out. Solid to gas, heat is taken in, which is correct, and it's called sublimation. That's correct. Liquid to solid, heat is given out. That is correct. It's called condensation. No, it's called freezing. So C is the answer. Gases are separated from liquid air by fractional distillation. The boiling points of 4 gases are shown. Which gas is both monoatomic and a liquid at 200 degrees Celsius, minus 200 degrees Celsius? So something that is a liquid at minus 200 degrees Celsius should have its boiling point above minus degrees Celsius, right? So we have got 2 options. It has to be a monoatomic, so argon is monoatomic and nitrogen is not. These are not the options. We can rule them out because they have a boiling point below 200 degrees Celsius, minus 200 degrees Celsius. Decane has a freezing point of minus 30 degrees Celsius and a boiling point of 174. A small sample of decane is placed in an open beaker in an oven at a temperature of 120 degrees Celsius and atmospheric pressure for 24 hours. What happens to the sample of decane? So sample of decane, what is its physical state? Minus 30 degrees Celsius is the freezing point. So between minus 30 and 174 degrees Celsius, decane is a liquid. It boils above 174. So at 120, it's clearly a liquid. So let's see what happens to the liquid. It boils, it doesn't boil, it boils only above 174. It evaporates, that's correct. It melts, no. It sublimes, no. A mixture of ice and water is left to stand and the ice melts. Which row describes what happens as the ice is melting? So when the ice is melting, the temperature of the mixture will stay the same. As we discussed earlier, the temperature will remain constant when the substance is changing state, so it will stay the same. And energy changes. Average kinetic energy of the particle increases. It doesn't, because temperature remains the same. Energy is used to overcome attractive forces, which is right. So this is the answer. Which test is used to show that a sample of water is pure? Evaporate the water to see if any solid remains. No. Heat the water to check its boiling point. That's correct, because pure water will have a constant boiling point. Test with anhydrous cobalt chloride. That is for the presence of water. Use universal indicator paper to check its pH. It's not practical. So B is the answer. Different methods of separation rely on substances having different properties. Which property does distillation make use of? Distillation is all about the difference in the boiling point. When a dark gray solid element is heated, it changes directly into a purple gas. Which word describes this change? A solid to a gas is sublimation. Pure water boils at 100 degrees Celsius. What happens to the water particles when water boils? They gain energy and move further apart. That is correct. They gain energy and stay close together. No. They lose energy. They don't. So this is the answer.